Guys, I hope you had a great weekend, nice and sunny. We're back for another week. So we're continuing on with our linear relations unit. Last week we had a shorter week. We just covered first differences. I'm just going to go over that really quickly now just as a review, and then we'll pick up with rate of change. Okay, so first differences. So basically for something like this, you'll be given a table of data. Sometimes you're asked to calculate it, like on one of the worksheets last week, and sometimes you're just given it. So here, when you're asked to calculate the first difference, remember basically the first difference is what it's either going up or down by, okay? So in order to do that, you're going to take the second number and subtract the first. So in this case, you're going to have 75 minus 100, so that's negative 25. Okay, the sign makes a difference. So just make sure that you're always doing the second one minus the first, the third one minus the second, and so on. Okay, so basically you're calculating what this is going up or what it's going down by. Okay, so for the next one, it would be 50 minus 75, which is negative 25 again. And then the next one would be 25 minus 50, which is again negative 25. Okay, so you can note two things here, okay? The first thing, I have a question at the bottom, which is linear or non-linear, okay? And the rule is if you, after you calculate your first differences, okay, if you look at the first differences and they are all the same, okay? Doesn't matter if they're positive or negative, but if the number is all the same, if the number is the same, then it is linear. Okay, so this is a linear. Okay, so I'm just going to write that rule down because it is an important rule and one that you should remember. Okay, so I'll just write it here. So if first differences are all the same, you have a linear relationship. Okay, and that means that if you graph it, you would expect a straight line. Okay, so that's what it means to have a linear relationship. Okay, so it's linear. The other thing you might notice is that they're all negative. Okay, we're going to kind of talk a little bit about that today, which is the rate of change or the slope of a line. So if I was to graph this, because all my first differences are the same, when I graph it, I would expect to have a slope like that. Okay, so this is a negative, and I'm getting a little bit ahead of myself, but this is a negative rate of change. Okay, and this is a positive rate of change. Okay, so don't worry too much about that because I will talk about it again. But I just wanted to kind of note that because they're all negative here, okay? But the key thing is that if the first differences are all the same, you're going to have a linear relationship. Okay, so that's kind of the review from last week. So new stuff that we're going to do today is we're going to talk about rate of change, okay? So rate of change, you can also, you may have called this in elementary school, you might have called this slope. Okay, same thing. So slope of a line or the rate of change of a line, it is basically a measure of the steepness or the shallowness of a line. Okay, the way that you calculate it is this. So you can just remember this equation. So the rate of change is equal to the rise over the run, okay? So for now, you can just copy that down somewhere in your notes where you're making notes. And then what I'm going to do is go over a few examples that shows you how to calculate the rate of change using the rise over the run, okay? Okay, so this is a bit of a trickier unit for me to teach in this way, making videos, okay? So I'm going to do my best. Sometimes it'll take me a bit because I have to kind of draw out a line here. So I'm going to make a graph, which is not ideal to do here, but I do want you guys to see it. So if you have paper in front of you, which you should for the lessons, I would suggest kind of copying out the graph as I'm making it as well, okay? So our first example, it's flight times of a Canadian goose. Okay, so it had a GPS collar on it, and this is flight times of a Canadian goose. Okay, so that's just the title of the graph. So my graph is not going to be perfect, but we're going to just kind of do our best here. So on my dependent axis, my y-axis, it's distance in kilometers, okay? And along the bottom, my independent axis, my x-axis, it's time in hours. Okay, so now I've labeled my two axes. I'm going to put the scale on. Okay, this is good review for your graphing as well. So my scale for my hours is going up by 5s. Okay, so 0, 5, 10 hours, 15, 20. Okay, and my distance, okay, so as long as I'm continuing with a set scale for each axis, the scales don't need to be the same, but here I couldn't go up by 5s and then say skip and go up by 10. Okay, just a quick review there. Okay, so here we're going to go up by hundreds. Need to go up to about 800, so 300, 400, 500, 600, 700, 800. Okay. We'll go up to 900. Okay, so I'm just going to put my point. So if we were in the classroom, this would just be up on the smartboard, okay, and we'd all be looking at it. But for now, I got to put it on here. So a couple points. One is 288. So 2, that's about 2.5. So 2 is going to be here. 88 is going to be just below kind of 100. So that's going to be the point 288. Okay. Just put a few points on. 9, so that's before, that's around 9, and 396, that's going to be just below the 400, so say that's around there. Okay, so that point is 9 and 396. So 9 hours, the goose has gone 396 kilometers. And I'll just put one more point on, so that is 20 and 880, so just below the 900, so around here. Okay, and that's 2880. So I'll just connect that. Okay, this doesn't look very good, but this should be a straight line. Okay, I apologize for it not being a whole lot neater. Okay, so let's just pretend that's a nice straight line. Okay, so that is what you would see in the classroom. You would have a nice graph in front of you, and the question is, calculate the rate of change. Okay, so rate of change, you'll see that quite a bit. Rate of change, just rock, okay? So your first step, I'm going to write out the steps. First step is to pick 2 points, okay, on the line. Okay, so that would be my first step. So let's say I'm going to choose that point and that point. Okay, so I'll just write them over here. So I've got 20 and 880. Okay, so remember each point is x, y coordinates. So my x coordinate is 20 and my y coordinate is 880. Okay, so that's 1 point. And the other point I've chosen is 2 for my x coordinate and 88 for the y coordinate. Okay, there's my 2 points. The second step you're going to do is you are going to stack the 2 points. Okay, meaning like one point is stacked on top of the other. Okay? Okay, that's easy. Third step is you're going to calculate the rise. Okay, so the rise is, I'm going to put, rise is equal to the difference. Okay, and remember when you calculate a difference, you are subtracting. Okay, so subtract. It's the difference between the two y coordinates. Okay, so each point is an x coordinate and a y coordinate. So if this is x, this is y, this is your y coordinate for one of your points, and this is the y coordinate for another point. Okay, so your rise, you're going to subtract the two coordinates. Okay, so that's to calculate the rise. Your run is going to be calculated by finding the difference. Okay, so again, subtracting the difference between the two x coordinates. Okay, so here's the one x coordinate, here's the second x coordinate. Okay, and then your fifth step is going to be calculating your rate of change, which is dividing your rise by run. Okay, so there's the steps that you are going to follow every single time you're asked to find the rate of change. Okay, pick your 2 points on the line, stack them, calculate your rise, which is your difference in your y coordinates, calculate your run, the difference in the x coordinates, and then divide rise by run. Okay, so I'm going to do that. I've just written out the steps first. Okay, so I'm going to calculate my my rise. Okay, and my rise is going to be 880 minus 88. Okay, so what's that going to be? 796, I believe. Okay, and then my run is going to be equal to the difference in my x coordinate, so 20 minus 2, which is 18. Okay, so now I've done steps 3 and 4. Step 5 is to actually calculate my rate of change. I'll do down at the bottom. So my rate of change is equal to my rise divided by my run. And I've figured out my rise is 796. And my run is 18. So I'm going to divide those two. And I don't have my calculator on me here. So I'll do it quickly here. So 796 divided by 18 gives you 44.2. 44.2. Okay, so that is my rate of change. And you say, okay, well, what is rate of change? Well, in this case, it's going to be the kilometers by hours. Okay, so the rate of change is equal to 44.2 kilometers per hour. So that is how fast this this particular goose is traveling. 44.2 kilometers an hour. It's pretty fast. Okay, I'm going to keep these on here. I'm going to use my other board because I'm going to refer back to these steps. Okay. Oh, you know what? This should be 798. Okay, so we don't need this. We'll go over our second example. And then you guys are going to have some questions to try on your own. Okay, second example. Okay, so you might have noticed that in the last example, Yeah. Okay. Sorry, I gotta go back to this because it's gonna bother me. In here, this should be 792. So 880 minus 88, okay, is equal to 792. And then if you go down here and you divide 792 divided by 18, you're gonna get 44 even. Okay, so 44 even. Okay, sorry about that. Okay, so we're gonna go on to our second example, which is this one. Okay, so I'm gonna start out by making the graph, and you can make it at the same time as me. This is about this girl Jennifer, and it's her gross pay over time. Gross pay over time. Okay, so that's the title of my graph. She's working at a construction site. She works different hours each week, and we are going to calculate her rate of pay. Okay, so our graph is going to look something like this. On our y-axis is pay in dollars. Okay, so that's our dependent axis, that's our y-axis. And along the independent axis or the x-axis, so I'll just put the y, x, is time in hours. Okay, so how long she's worked and basically how much money she's getting. Okay, so we put a few points on, or first I'll do our scale. So the bottom, this is going to go up by tens. 10, 20, 30, 40, we'll go up to 50. And her pay is going to go up by hundreds. So 0, 100, 200, 300, 400, and we'll go up to 600, 500, 600. Okay, so put a couple points on. So one point is she works for 4 hours. So this is 5, so 4 is around here. And she makes 56 bucks, so just over halfway. So that point there is 456. Another point is 20 and 280. So she works 20 hours, she gets 280 bucks. So that's going to be somewhere around here. So that's 20, 280. And I'll put one last point, and that's 40 hours. 40 hours and $560. So that's going to be somewhere around there. So 40 hours, $560. Okay, so let's connect this. It should be a straight line. See if I can make it a little better than the last one. Okay, something like that. Okay, so the question is that you're given is to calculate her rate of pay. So the rate of pay is her rate of change, right? How is the pay going up in terms of the hours? Okay, so rate of change. That's what we need to calculate. So recall, if I can refer back to this, I'll look at the first two steps. So pick 2 points on the line and stack the 2 points. Okay, so we'll do those 2 steps. So why don't we, these are kind of nice numbers. Let's pick this point this time and this point, and we're going to stack them. Okay, let's write them here. So I've got a point, 40 hours, $560. And then I've got the point 20, 280. Okay, so recall this is X and this is Y, right? Every point has an X coordinate and a Y coordinate. Okay, so we've picked our 2 points, we've stacked them, which means we've done steps 1 and 2. Now we go to step 3, which is to calculate the rise. That's the difference, or in other words, subtracting between the 2 Y coordinates. Okay, so that's the rise. It's easy to remember that the rise is the difference in the Y coordinates because this is the Y axis, right? And the Y axis has to do with rise, The x-axis has to do with a run, right? You're going up and down. So the rise is going to be the difference in the y-coordinates. So 560 minus 280. And I believe that's 280, but I don't really want to make another mistake. So 560 minus 280 is 280. Okay. So that's my rise. Okay. My run is the difference in the x-coordinates. So my run is going to be 40 minus 20, which is equal to 20. Okay, so here's my rise and here's my run. Now my rate of change is going to be equal to the rise that I've calculated divided by the run that I've calculated. So that's 280 divided by 20. That should be 14. Yeah, so 14. Okay, so basically that means that she is making $14 an hour. Okay, so when it asks you, a question might ask you, you know, what does the rate of change mean? That's when you have to look and say, okay, what's on my y-axis, what's on my x-axis? Because I've calculated the rise, which is the dollars, divided by the time, okay, which is hours. So it's $14 an hour. That's what the rate of change means. Okay. I just want to point something out before I wrap this lesson up. So you've calculated your rise and your run. I just want to make one note. I'm just going to erase part of this so I can write here. Let's say you have a point on a line that is 216, okay, and another point that is 4.8. Okay, let's say those are your 2 points. And you go to calculate your rise, okay, and you know that your rise is the difference in the y-coordinates. Just give myself a little bit more room. So my rise is the difference in my y-coordinates, so it would be 16 minus 8, so that's 8. Okay, and my run is the difference in my x-coordinates, okay? And you might ask yourself, you might be tempted, as some students are, to go 4 minus 2, okay? Because you want to get a positive. But the key thing is that you always have to subtract in the same direction. So if this is 0.1 and this is 0.2, and you are subtracting the y-coordinate from 0.1 from the y-coordinate in 0.2, as this is the 0.1, this is 0.2, okay? You have to do it in the same order for the rise, okay? So in this case, I would have to go 2 minus 4, which is negative 2. Okay, it's okay to get a negative number. It just means that your line is going to be going down as opposed to what we've done in the examples, which is going up, okay? So then when you go to calculate your rate of change is your rise divided by your run, so 8 divided by negative 2, so that would be negative 4, okay? So just be careful that you're always subtracting in the same order, okay? Your y-coordinate from 1, subtract your y-coordinate from 0.2, your x-coordinate from 0.1, subtract your x-coordinate from 0.2. Okay, that didn't come up in the examples, but it may come up in some of your homework questions. Okay, so this time, instead of a worksheet, I have some textbook pages, okay? So I'm going to send out a PDF of textbook pages that you need, and your homework is going to be this, okay? So homework is page 199, questions 1 and 2, and page 203, questions 1, 2, 4, and 7. Okay, so those are the questions to try. This week I'm going to do 2 lessons on rate of change because it's kind of an important concept. for things that we'll be doing further along the way and for next year in grade 10 as well. So today's lessons, the Monday, Tuesday lesson, this is your homework. I'll do another lesson for Wednesday, Thursday on rate of change again, and there'll be a worksheet to practice questions. Okay, so the more you practice, the rate of change will get simpler. Okay.